All right, my last two examples then to finish off this particular note, we want to add these two vectors together. So my resultant is u plus v. Okay, so what we want to do is we want to add those two vectors together. So you need to give yourself a sketch of it here. So there's my u, and there is my v. So the u vector, the v vector. Now, I'm going to place some horizontal lines on here, maybe make things a little bit clearer, and I'll use the green here. So, there's a horizontal line, and there's a horizontal line. You got to remember, I'm not drawing this to scale. So, this may or may not look like the final product. So for argument's sake, oops, I'm going to cheat a little bit here. I'm going to move that v vector below. Okay, just so it doesn't look like it's perfectly horizontal. All right, and as we move through here, we need to know some magnitudes here. So I'm going to tell you that this vector is, let's go with 10 units. And we'll go with this one being 8 units. All right, so here we go. I have my horizontal lines. I know that from my original diagram that it's 30 degrees with the horizontal. Because these two lines are parallel, this angle up here will also be 30 degrees. I'm given that this angle is 70 degrees. So that means I can find this internal angle of 180 minus 70 minus 30. So this is going to be 80 degrees inside the triangle, which means I now have a side, an angle, and a side. So the steps, that's the step 3. That was the one I said would be the most challenging. Step 4 is use cosine law to determine the magnitude of your resultant. So the magnitude of the resultant, from our cosine law, looks like this. So magnitude of u squared plus magnitude of v squared minus 2 multiplied by magnitude of u, magnitude of v, cos theta. Remember, it's a squared plus b squared minus 2ab. Well, now we're doing lengths of vectors. So, and this is actually the formula I do prefer. So you may want to do this on your cheat sheet. It just saves some steps. So this is what I would recommend putting on your cheat sheet. And it's just the cosine law solved for the unknown side length. So there you go. That should definitely make it on the cheat sheet. Solving, magnitude of r equals 8 squared plus 10 squared minus 2 times 8 times 10, and we got the angle to be 80 degrees. So now, you just have to punch it through the calculator. Down a little bit. So, clear it out. So, 64 plus 100 minus, and in brackets, 2 times 8 times 10 times 80, 80 closing bracket, equals, so 136.21. I'm going to take the square root of that answer. So, my square root button, oh, I'll just take it to the exponent, maybe. Yeah. My square root button's not handy, so I'm just going to take it to the exponent 0.5, which is the same as the square root. And you should get 11.7. 11.7. So the magnitude of the vector is 11.7 units. I want to find the angle. So that means that I want to find the angle of the resultant vector. And the resultant vector is this one right here. It goes along the diagonal. So that is the resultant vector right there. So I need to find the angle, and I want to find the angle from vector u. So this is what I'm going to look for. So that means I've got to use the sine law. So I am going to use sine of the angle I want, sine phi, so I'll label it as phi, divided by magnitude of v, the vector across from it, and that's equal to, and you always use the resultant vector, so sine theta over the magnitude of the resultant. Okay, so sine phi is what I'm looking for. I'll do some number substitution. V is 8 units, and that's equal to the sine of 80 degrees divided by the 11.7. So we're just solving for phi. So sine phi equals 8 sine 80 divided by 11.7. So that angle in question is, using your calculator, and I get it to be 3.6 degrees, so something that's fairly low here. 3.6 degrees, so that's 5. So that's actually drawn incorrectly, okay, but that's fine, because it's just a sketch. So therefore, my resultant is 11.7 units, and measured 3.6 degrees clockwise from the u vector. Okay, so from u. So that means that if I was pointing in the direction of the u vector, all right, over here, and I was to rotate clockwise, meaning that direction, I would rotate 3.6 degrees. So actually my resultant looks like this. It's more like that is what the resultant should have been. All right. Moving on to my final example, it's just u minus v, so that means my resultant is equal to u, take away the v vector. So again, you give yourself a sketch. So here's my u vector. And again, I got to give the size of these units, so let's stay with 10 units and 8 units, just to keep it simple. The v vector, it should be here, okay? But because we're subtracting, I got to swing it around. So I end up with a vector down here. So here's my negative v. So I get rid of that. I'm going to keep it for a second, actually. So that means my resultant, the resultant vector from this situation, is going to be right here. So there's my resultant vector. So I need to get some angles. And again, I'm going to draw in the horizontals. So I have that one there. And now my other one's going to be here. So let's talk about that for a second. Ooh, that one's not very horizontal. Someone should have said something on that. There we go. We got to find an internal angle here. So what can we find out? Well, I can tell you that I see a Z pattern. And this, like I said, this is always the hardest part. My Z pattern, the green dashed lines are parallel. So here's my Z pattern, which would tell me that this angle and this angle are equal. I know that the u vector is 30 degrees below the horizontal, so that will be 30 degrees there. The v vector, I know this angle is 10 degrees, and I have two lines that are intersecting here. So use magic pen. This line and this line are intersecting. That creates the x pattern. Okay, that's our oat, which means that this angle would also be 10 degrees, which means that large angle inside the triangle is 40 degrees. Okay? That's the hardest part, because once you have that, you're all set to go. What's the first step? Well, you always have to use cosine law. This is the one off the sheet or off the previous example. It should be on your cheat sheet. We're going on your cheat sheet. So I do need to see this. And now you just plug in your numbers. So again, I used 10 and 8, so I didn't have to think too much on this one. 10 and 8, and the angle we discovered was cos 40. So now it's just plug and chug. At that point, you have the majority of the mark because you've done the thinking for me. Okay, so keep that in mind. So any mistakes after this don't affect the mark a whole lot at this point. So 2 times 10 times 8 times 40 cos, close that bracket, equals, and I can't find my square root button, so I'll just do 3.5, and it's negative 81. What did I do wrong here? One sec. Okay, I don't know what I punched in wrong, but anyway, it's now fixed. So I get 6.4 with the calculator, and that's units. My angle is the tan inverse of, nope, it's not tan inverse, it's sine law, sorry. So now we have to find the angle at which the resultant is going. So I want this angle up here, which I will call phi. So sine phi divided by magnitude of v is equal to sine theta, the angle we just found, or found originally, over magnitude of r. So sine phi over b is 8 units, sine of 40 degrees, and we just found it to be 6.4. Solving for sine phi, or solving for phi, we get it to this stage. Using your calculator at this point, I get 8.4 degrees on the calculator. So then summarizing, I know that my resultant is 6.4 units long, and my direction would be 8.4 degrees clockwise from vector u. Okay, and there we are. So the worksheet involved with this, this would normally take 2 days for me to go through. So I know there's 33 videos, so it is a little bit frustrating time-wise, but you can start some of this and work on it in class in terms of the homework, and then you can also start it to the next video, kind of work your way ahead. All right, so any questions with this, please let me know, and good luck.